Okay, the recording goes on. Okay, recording is I'm streaming it. Yes, we can start now. Yes, good evening, all of you. Walaikum salam. Alhamdulillah, good. Yes, hi. We can begin now. So without a further delay, let's start, right? So I had sent this paper in the Master ID WhatsApp channel, right? So if I had gone through the channel, you would have noticed the paper was available there. Okay, so that's the paper I'm going to discuss here. For those who aren't, those who don't have that paper, I'll reshare it in the chat now. So if you are one, you can just have it for now. Is it Rishta? Maybe. Yes, so let me just share the link. And yeah, wait, that message is unstructured. Sorry, ignore that message. I'll now share in the chat the PDF link. Wait, copy. Yeah. Sorry. Okay, let's start. So this was a zonal paper, and we'll try as maximum to complete the paper on time without a further delay. A minute, give me a minute, and yeah, let's start. So in this question, they have mentioned the first question they had mentioned. I hope you all did the paper. At least you all tried doing certain questions, so you can answer, mark with me as well. But yeah, let's check. I couldn't do the paper because I got it just now. Didn't you check the channel? Okay, that's fine. Okay, so listen to the discussion then. The first question said match the e-government services example using numbers and labels, right? Normally, if you take ICT, one of the services of ICT, that is where ICT can be used, is something called as e-government. E-government is where ICT is going to be used by the government to conduct its activities, right? So when ICT is used by government, based on who is going to get that service, who's going to obtain that service, we can categorize this service into four categories. One is G to G, which stands for from the government to government. That is, for example, let's say Sri Lanka is one government, India is another government. So let's say there are certain services India can obtain from Sri Lanka's government website. So that's going to be from one government, another government is obtaining services. G2B stands for government to businesses. So, for example, if there are any businesses in Sri Lanka, there are certain services they would want to obtain from the government, like registering their business. Those are coming under G2B. G2E stands for government to employees. That means the government employees, not the other employees. Mainly, we are referring here to the government employees. So, there are certain services government employees can obtain from the government, right? So, the information about those services, again, you can obtain through a website. So, that's also going to come under G2E. And G2C stands for government to citizens. So all the people living in Sri Lanka, we can call ourselves as citizens of Sri Lanka. And all the services we can obtain from the government, you can classify them as G2C. Okay, so let's see which one comes under which category. Gazettes and circulars. Gazettes are like, for example, notices. Okay, the gazettes and circulars, they're like some notices for the released by the government. Tell me, gazettes and circulars, they are respective to whom? G2B is government to businesses. Correct. That's for government to employees. Okay. So normally, for example, let's say there's a notice they're going to tell hereafter for all the government employees, what do you call hereafter there for all the government employees, they're going to, let's say, apply a certain rule. Then normally they'll release that rule or they release that notice as a gazette. So gazettes are like notice. So they release that notice. Most of the notices can come under citizen as well as employee. So certain gazettes are respected to citizens, certain are respected to employees. It can come under both the categories. But in this situation, it suits for employees, but I'll keep it without connecting. It could come under employee or citizen. I'll just keep it for now unmarked. I'll just keep it roughly marked here. Embassy and visa facilities. Those are related to who? Normally, who will need to know Sri Lanka's visa information? Like if you're in Sri Lanka, you don't have to. Normally, if you want to go to another country, right? If you want to go to another country, apart from having a passport, you need something called visa, right? So for Sri Lankans, if you're already in Sri Lanka, then you don't have need visa. Obviously, you need visa. You're going for another country, right? So who will need Sri Lanka's visa information? Exactly. The other government people, they will only need Sri Lanka's information, Sri Lanka's visa information. Exactly. Right. So therefore, that's going to come under G to G. Okay, that's going to come under G to G, government to government. Other government people only, they will know, they will need Sri Lanka's visa information, right? So G to G. Passport facilities. For example, let's say you want to apply for the passport, okay? The people of Sri Lanka, we want to apply for the passport. So the details about the passports, let's say we can go and obtain from the website, like how to apply for passport, where should I go to apply for the passport. So these passport related information, who is going to obtain? The people of Sri Lanka. So how do you call ourselves as? Correct. We call ourselves as the citizens of Sri Lanka. So that's going to be obtained by G to C. The passport details are going to be obtained by the citizens G to C. Okay, perfect. And then the stock market information. Now, if you all are going to Python's class, you would have told about stock market, all those stuff. So if you have seen the movie which came recently as well, that had. Okay. So stock market is something related to, exactly, something related to businesses. Correct. That's going to be G to B. Yes. So if you match them properly, this is how it can come. Again, the gazettes and circulars, it can come for our citizens as well. But here you can see the passport facility is more suitable for citizens. Therefore, I put the gazettes for employees. Huh? If you have any questions, drop in the chat. I think I missed some. If I missed some questions, just resend it. But I think I answered everything. What is G2B? G2B stands for government to businesses. That means, for example, if there are any businesses in Sri Lanka, what are the details they will need from the government? Like, for example, how to register business, then business related laws. Then there are some special loan facilities for businesses. No need for movies when news exists. Yeah, news also contains those stuff. Okay, next. Perfect. How to identify whether gazette belongs to employee or citizen? Depending on the other answers. Like that's why I'll keep that as a tentative answer. Let's mark that as a pencil and go for the remaining answers. So the remaining answers you can correctly match for the remaining, then your answer is correct. But if you feel like, okay, we can't match this one answer, then your answer can change. So if you got this correct, put half marks each. Total 2 marks. Next. A circuit has two switches, A and B, and a bulb called Q. Okay, there's a circuit, it seems, and the circuit has two switches. One is A and one is B. And there's a bulb called Q, it seems, right? When either switch A or B is, what do you call? When either switch A or B, when either switch A or switch B or both the switches are on, bulb is lit. Okay, fine. When either switch A or B, or else when both the switches are on, the bulb is lit. Fine, perfect. Write a Boolean expression to light the bulb. Fine. Normally, when you're talking about, this is a logic gate question, okay? Normally, when you're talking about circuits, you all know to represent circuits, we use diagrams. Like, for example, when I'm drawing circuits, in science, you might have learned how to drawing circuits. What do you call? We might use this symbol to represent a bulb. We might use this symbol to represent a battery. We might use this symbol to represent a switch, right? Those are not drawing the diagrams, right? When you're drawing the diagrams, you can see there's a amount of space used, like shapes used, right? So when you're drawing logic gates as well, you can draw diagrams using shapes. Like, for example, there's something called AND gate, drawn like this. There's something called OR gate, drawn like this. There's something called NOT gate, drawn like this. Now, this is where we are using certain diagrams to represent, or we are using certain shapes to represent what do you call a gate or a circuit, okay? Or a circuit. So without using these, without using what you call shapes, if you want to represent the same circuit, the idea of how the circuit is connected, if you want to represent the same thing without using any shapes, just using, let's say, only numbers and letters and symbols, for that we have something called as Boolean expression. So Boolean expression is where you can represent how a circuit is going to be connected, how are the things going to be connected in a circuit, but without using any diagrams, without using any shapes, just by using letters or numbers and symbols. Mostly you don't deal with numbers, but mostly it's going to be letters and symbols, right? Now, if you look at this question, they have said there's a bulb called Q. For that bulb to work, there are two switches A and B, which we are going to control. Okay. So they are telling out of this, what do you call A and B switch, if both the switches are on also, it will work. If either one of them is on also, it will work. Now tell me, out of the three basic gates we have, that is AND gate, OR gate, and NOT gate, tell me, for a NOT gate, can we connect both the switches? Can we connect two switches inside one NOT gate? No. If you take NOT gate can, now if you take all these gates, AND gate, OR gate, NOR gate, NOT gate, all these gates we have, these are basically certain, what do you call, certain instruments or certain circuits that can take a value, that can take, take signals from sensor. If you take NOT gate, it can take a signal only from one device. It can't take signals from multiple devices. So it can't go and check, are two switches on. If you want, it can go and do one thing, but it can't do two things. Okay. But if you take AND gate and OR gate, these two, it can take two. Okay. Now, based on how AND gate and OR gate works, if you take AND gate goes and checks, are we getting signals from all the inputs? Whatever all the inputs is, for example, if you take an AND gate like this, okay, imagine we have three inputs for this AND gate called X, Y, and Z. No, the inputs we put in the straight hand side, the output we mentioned the curved side. Huh? So for example, let's say we have AND gate that looks like this, X, Y, Z as input and P as output. AND gate goes and checks, are all these inputs giving us signal? Okay. If you take OR gate, giving us signal means, are we getting like current? Now, when you on a switch, current is passed through the switch, right? So likewise, imagine X and Y, Z, all three are switch. AND gate goes and checks, are all these switches on? Because only if all three switches give us current, AND gate will give us an output current as well. Okay. But if you take OR gate goes and checks, is any of the inputs giving us a signal? If out of all the inputs, if at least one of them give, we are good to go. A signal will be passed. That's why AND and OR gate works. AND gate goes and checks, are all the inputs giving us a signal? OR gate goes and checks, is any of the inputs, either one of the inputs, is it giving us a signal, right? So this is how the OR gate looks like. So for example, if I have three switches, X, Y, and Z, okay, let's say X is on, but Y and Z is off. And OR gate goes and checks, is any of the inputs on, or is any of the inputs giving us a signal? Or if X is going to give us signal, then yes, there will be output signal. That's how the OR gate works, right? Tell me, out of the AND gate and OR gate, for this situation, which gate do you think is more suitable? AND gate or OR gate? Based on what they have mentioned here. Yes, Shahima expert. Yes, Abdul Faiz. Exactly. It's the OR gate. Tell me, in the question, if this part was not there, if they had removed this part called either switch A or B, if they have removed this part and if they had mentioned the bulb will be on only when both the switches are on, like if they had mentioned only from this part, like if they had mentioned only this when both switches are on, bulb is lit. Like what I had in pink color. If they had mentioned only that pink color one, yes. If they had mentioned only the pink color one, then it's going to be the AND gate because there they have mentioned what? When both the switches are on, only the bulb is lit. So that means for the bulb to be on, if you know, we have only two switches connected, right? They have mentioned for this bulb, there are two switches connected. So out of the two switches, if you want both the switch to be connected, which means you want all the inputs to be connected, I mean all the inputs to be on, then that's going to be AND gate. If they're talking about any input has to be on, it's going to be OR gate, right? Perfect. So we're not talking about Boolean expression. First of all, you have to mention what are the inputs we have. What are the what do you call devices? We're going to get the signals. We're going to go and check is it on or off, right? So here you can see for the to check what do you call for the whether the bulb has to be on or off. We're going to check in a switch called A, and there's a switch called B. We're going to go and check is switch A on, is switch B on, right? I want to go and check is switch A or B on, right? So what is the symbol I should use in a Boolean expression to represent OR gate is used in between A and B? Yes. In a logic gate, to represent, I mean, in a Boolean expression, to represent OR gate, we use a plus symbol. So I can say A plus B. And normally when you're writing Boolean expression, it's not compulsory, but when you're writing Boolean expression, apart from mentioning the input, it's better you can mention the output. So you can mention it A plus B is equal to Q, or else Q is equal to A plus B. Both are correct. Q equals A plus B. So that means to get the output Q, either A gate or else B gate has to be on. So this is how you have to mention your answer. If you mention like this, you get 1 mark. If you have any questions, drop in the chat. Those have any questions, drop your question, like your exact question in the chat. Huh? So if I'm going to represent this in a circuit, in a diagram, the diagram would be something like this. Let me show you the diagram. If I'm going to represent this in a diagram would look like this. There is a and B switch connected to a OR gate, and the output of A and B is connected to Q. So here all you can mention Q is equal to A plus B. Not compulsory. If you want, you can add for this part, not compulsory. Can I put A dot B? No. Dot is AND gate limit. Yes, Catherine. They're reading either A or B or both is needed for the bulb on. Yes. So what they mean by that is this. For example, if you take the truth table of A and B, it look like this, right? Like OR gates truth table 0101 0011. The OR gates truth table will be like this, right? So if you notice here, when only B is on also, bulb is on. When only A is on also, bulb is on. When both are on also, bulb is on. That is what they mean by that. Got it? This is only one B is on, only A is on, both are on. That's what they said. When either one of them are on, or else when both are on. Make sense? No, both are same. Okay, perfect. Next. What will be the state whether it's on or off of the bulb when switch A is off and switch B is on? Okay. Now in the truth table, 0 represent it's off and 1 represent it's on. Okay. So they are saying when switch A is off, that is when A is off and B is on. That means they're talking about the second one. The second situation, when A is off and B is on, what will be the status of the bulb? On or off? Exactly, bulb will be on. So if you wrote here bulb will be lit, that's also correct. If you mention bulb will be on, that is also correct. Should we try the truth table along the Boolean expression? No, I just draw the truth table to explain the previous doubt a person asked about what do they mean by that both the switches on also. So if you had mentioned what you called here the Boolean expression, you get 1 mark. And if you had mentioned the bulb will be lit, you get 1 mark. Both, that's fine. Lit or on, both if you mention also fine. If you have any other doubts, drop in the chat. Huh? Can we just write lit? Yes, if you just wrote lit also, you get marks. Just lit is also correct. Perfect. Next. Consider the following logical circuit diagram. Write the Boolean expression to the output x. Okay, they're asking what is the value of x. Normally, if you want to write the Boolean expression of the final output, make sure that you find the output of each and every gate from left to right. So from left to right, when I start, I have a NOT gate here. So from this NOT gate, but you can also look at the red color markings. So from when A goes to the NOT gate, A becomes A dash. Okay. And when B comes here, B comes directly. There is no change, B is going. Right. So this is the NOT gate. When an input goes to the NOT gate, what will happen is above the input, we mention a dash. So here you can see A is the input. When A goes to the NOT gate, A will get a dash. Then the next gate we have here is the AND gate. To find the output, first of all, you should know what are the inputs coming now. So if you look at this AND gate, from the top, the input we have is A dash. From the bottom, the input we have is B. So keep a small space and write the next input. So step number 1, take a gate and write all the inputs we have with a small space. Then in between the, what do you call inputs, you have to mention the symbol. To represent an AND gate, the symbol we use is a dot symbol. So here it's going to be A dot, A dash dot B. Okay. Now I'll come for this NOT gate in the bottom. If you look at this NOT gate, the input that's coming for this NOT gate, you can see it's coming from B. So when B goes to the NOT gate, I told you, first of all, write the input and then the symbol. The symbol to represent NOT gate is dash. So B dash. And then this B dash is going to the OR gate. Okay, this gate we call as the OR gate. From bottom, we have C coming. Okay, if you look at that OR gate, from the top, we have B dash. From the bottom, we have C. To write the output, first of all, you should know the inputs. No. So first of all, mention the inputs. The top input is B dash. Bottom input is C. In between the inputs, you mention symbol. To represent OR gate, the symbol we use is plus. So that's going to be B dash plus C. Now I go for my next gate. The next gate I have, from the top, I'm getting A dash dot B. From the bottom, I'm getting B dash dot C. Tell me, what is the name of this gate, first of all? In front of the AND gate, we have a small circle, right? So if in front of the AND gate, if you have a small circle, how do you call this gate as? Correct. We call this gate as a NAND gate. Perfect. Yes, we call this gate as a NAND gate. Normally, when I ask you all these general questions, like what is this, what is that, put in the main chat. And if you have doubts, put in the private chat. So, sending in Zoom, in a Zoom chat, you can directly send a message. That's a public chat. The left side top corner, there will be like a pencil icon or a pen icon. So you can click on that and send in the private chat. Your doubts. Okay, that's fine. Next. So now let's take a look at the NAND gate. For the NAND gate, the input that's coming from the top is A dash dot B. So first of all, I'll write A dash dot B. The input I'm getting from the bottom is B dash plus C. So I write here B dash plus C. Now we have two inputs, right? A dash dot B is one input, B dash plus C is another input. Now tell me, if you look at this input, each of these input, does the input have only one letter or does the input have multiple letters? One or multiple? If you look at the input that's coming from the top, as well as we look at the input that's coming from the bottom, each of these input has only one letter or each of these input has multiple letters. Multiple means more than one, no? Exactly. There are multiple letters. Always keep in mind, when an input has more than one letter, you go and check first after you wrote the input separately, check does your input have more than one letter. If your input has more than one letter, add a bracket for it. So this will have one bracket and this will have another bracket. So now I have one input as A dash dot B, other input as B dash plus C. After you have both the inputs like this, now you represent a symbol. To represent NAND gate, we use two symbols. The first symbol is in between the inputs, you have to mention a dot. Second symbol is on top of the whole thing, you have to mention a dash. Okay, on top of the whole thing, you have to mention a dash. So this is how X will be equal to. So the Boolean expression to write the output of X is going to look like this. If you wrote this, put 1 mark. If you have doubts, drop in the chat. Next, construct the truth table for the above logic circuit. Okay, when you're drawing the truth table, first of all, you have one column each for every input. If you look at the whole circuit, in the left side corner, you can find the inputs. No, A is one input, B is another input, and C is another input. So I had to have one column for A. I had to have another column for B. I'd have another column for C. So A, B, C is representing my inputs. Then for every gate has output, right? So every gate's output, you have to mention, can you put double dash? Why do you want double dash? To represent NAND gate, we have two symbols, dot and whole thing dash. It's right. Nothing else. So no double dash here. Okay. So I wrote the inputs as A, B, C, and now every gate's output has to be mentioned. So the first gate we have, the first NOT gates we have, the output of that is what? A dash. So I'm going to have one column for A dash. Then if I look at the second NOT gate here I have, that one's output is going as B dash, right? So I'm going to have another column for B dash. What is it, Nafa? So the final expression, if you put dot, is it enough? No. The final expression should be exactly like mine. In between the inputs dot, the inputs has to be in brackets, and over the whole input you have the dash. How I added in green color. I'll come to that, Nafa, right? Okay, A dash is going to be one column. Then the next input is going to be B dash. So right, B dash is another column. Then if I take this AND gate we have here, the output of the AND gate is what? A dash. Okay, I don't have space here. So I'll draw it in the bottom somewhere. I'll write it here. So I'm going to have one column for A, one column for B, one column for C. Avoid using the chat unwantedly. Rizlan says, I'm using Rizlan's Zoom account. If it was my account, I can delete the chat. So in this Zoom, I don't have the option to delete the chat. So because I don't have the delete the chat, I'll directly put you out of the Zoom meeting. Simple. I will not delete the chat. I'll put you out of the meeting. I didn't put the brackets wrong. Yes, 0 marks. Your answer is wrong without the brackets. If you remove that person. So, remove. Okay, done. So ABC has one input and every gate's output. So A dash is one output, B dash is another output. And then the AND gate's output is A dash dot B. The OR gate's output is B dash plus C. And the NAND gate's output was A dash dot B. The whole thing. Is it like now? Is it compulsory and dash and B dash? Not compulsory. This will avoid mistakes. Out of all these sums are all the inputs, that's ABC, and the final output. The compulsory columns are only these. Other columns to avoid mistakes. So there's a high chance that you could go wrong. There are no probabilities, right? So it's based on probabilities. Huh? Lagging. Give me a moment. Now is it okay? Give me a moment. I'll off this in a moment. Am I lagging at the moment? Send the private. Okay, if you want to main chat, please. Am I lagging at the moment? The main chat is out. Perfect. Okay, right. Let's start. Okay, let's start. So we have ABC as input, and these are columns. So out of the yellow color, highlighted columns are important. Other columns better to add to avoid what you call losing marks. Okay. So every gates output I have mentioned, and every inputs I have mentioned. Right. If you look at the circuit, you can see there are three inputs. Right. Now we are drawing the truth table. There could be multiple rows. You can design. Okay. There's the equation that says what do you call. So normally each row represent a combination. Right. We call that as a combination or a probability possibility. So I'll avoid explaining all those now. We'll take on more time, but I'll just give you the idea. The number of rows that truth table will have is equal to 2 to the power the number of inputs. 2 to the power of number of inputs. If you look at this, so tell me if there are 3 inputs, how many possible rows would be there? It's lagging again. Why am I still lagging? Let me change the network rate. How about now? Am I lagging now? No, no. Samir, yes. All good? Okay, I change network. Fine. So we use this equation 2 to the power number of inputs to find how many rows will be there in this what you call truth table. Okay. So 2 to the power 3 is equal to how much? That's equal to 8. So that means this truth table will have 8 different rows. So 1, 2, 3, 4, 5, 6, 7, 8. Not bad. I have drawn the rows in Kanapar correctly. So now I'll tell you how you fill this truth table. Huh? Always start with the right side corner input. So out of A, B, and C, in my right side corner, the input I have is C. So just fill that 8 rows in the pattern of 0, 1, 0, 1, 0, 1. Just fill in that pattern. So once you have filled in that pattern, go for the next input, I mean the next column, next input column, and double it. So here you had 1, 0 and 1, 1, 1, 0, 1, 1. No. Here you have 2 zeros, 2 ones, 2 zeros, and 2 ones. Then you go for the next input and double it. So double of 2 is how much? 4. So then you find 4 zeros and 4 ones. Okay, 4 zeros and 4 ones. 2 is constant or will it change according to the equation? These are the equation, man. That's constant. Number of rows is equal to 2 to the power number of inputs. So you can see in this program, the inputs mean the main letters that's in the left side corner you can see. So here we have the letter A, letter B, and letter C. These are 3 main inputs. So that number of inputs is the only part that can change. The number two is always constant. The number of input is basically that can change. You can the other way, but avoid that. Okay, perfect. Now we start filling this table. When you say A dash is representing the opposite of A column, right? So if A is 0, A dash is 1. 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 So basically, you take the A column, this whole column, and you write the opposite of that in A dash column. So that's 0, 0, 0, 0. So if you compare that first column and fourth column, you can see the fourth column is the exact opposite of the first column. Now B dash means opposite of B column. So I take the values of B and inverse it and write. So if B was 0 here, B will be 1 here. If B was 0 here, B will be 1 here. So exact opposite of that I'm writing here. Next we have A dash dot B. When you say A dash dot B, you can see we have to take the A dash column and B column. So this is A dash column. This is the B column. And when you say A dash dot B, the dot is representing the AND gate. Okay. And how does AND gate works? AND gate goes and checks, are all the inputs present or are all the inputs one? Okay. So look at both the green color. That is this and this and tell me, are all the inputs one? Are all the inputs one in the first row? When you compare B, A dash and B, no. So that's going to be zero. Always in what you call a circuit, one is representing yes and zero is representing no. So you go with the second row and see, is A dash and B, are all of them one? No. Third row, A dash and B. Look at the third row and tell me, when you compare A dash and B, are all the inputs one? Like all the inputs for that AND gate, what are the inputs we have? A dash is one input, B is another input. So if you compare A dash value and B value for the third row, are all of our inputs one? Yes, all of our inputs are one. So we are going to mention one here. Likewise, if you go and check A is one, A dash and B in this row, it's one. A dash, sorry, in this row it's zero. In this row it's zero. In this row are all the inputs one? No. In this row are all the inputs one? No. Okay. So you go and check, are all the inputs one for this AND gate? For this AND gate, the inputs are what? A dash and B. That's why I compared only those two rows. And I got this column. Now I go for the next column. The next column is talking about B dash plus C. So I take the B dash column. We'll take this B dash column and C column. So B dash is what? This is the B dash column, the pink color highlighted. And this is the C column, the pink color highlighted. And you can see in this expression, we have used plus in between. The plus represents OR gate. OR gate goes and checks, is any of the inputs one? Okay. So when you compare the first row, the two pink color highlighted in C, is any of our inputs one? Yes. Is any of our inputs one in the second row? Yes. Is any of our inputs one in the third row? Yes. Is any of our inputs one in the fourth row? Yes. Is any of our inputs one in the fifth row? Yes. Is any of the inputs one in the sixth row? Yes. Is any of the inputs one in the seventh row? What is the output in the seventh row? Actually, I made a mistake here. If you take here in this row, both are zero. Sorry. Yeah, third row is zero. I know it is now. What is the output in the what you call seventh row? Yes, when you go and compare the value of C and compare the value of B dash, that's going to be 0. The last row, when you compare C and B dash, the last row, what is it? That's going to be 1. Because when you say B dash plus C, the meaning is we will take the value in B dash column, we will take the value in C column, and when you say B dash plus C, we're going to compare the value in these two columns using the OR gates logic. How does OR gate works? OR gate goes and checks, is any of the input 1? Any of the input means is either B1 or is C1. It goes and checks, is either one of them 1. So if you look at the B dash and C, I've highlighted in pink, the pink color column. So this is a B dash value. This is C value. I go and see, is any of them 1? Is any of them 1? Yes. So I mentioned 1. Here, if I go and check the one before the last row, is any of them 1? No. So I mentioned 0. If it's yes, you mention 1. If it's no, you mention 0. Got it, Samir? Perfect. Now you go for the next column, that is a dash dot b dash plus c whole thing dash. Now if you look at here, a dash dot b is represented using this blue column here. Blue column here is going to represent a dash dot b. Then b dash dot c is going to represent in this column. So you have to compare these two columns input only here, right? And what is the logic used here? We have used the NAND gates logic here, right? You can how I know it's NAND gate? So between the two inputs, a dash dot b is blue color highlighted, b dash plus c is the blue color highlighted input now. Between the two inputs, you can see there are two gates used. One is a plus and one is a dash. Okay. When you have plus and dash, both the plus in between the input and dash the full input, this represents what gate is being used. When you have a plus and whole thing dash, this represents what gate is being used. So dot plus dot in between the inputs dot and for the whole thing dash. Exactly. That's represented the NAND gate. So if you're wondering how NAND gate works, NAND gate is basically the opposite of AND gate. It's the opposite of AND gate. So what you're going to do is for all the rows, the blue color highlighted all the rows, what you're going to do is you're going to go and check first of all the AND gate's logic and then write the opposite of the AND gate. Okay. So how does AND gate works? AND gate goes and checks is all the inputs one. Right. So if you look at the first row, okay, again, we are comparing only the blue color highlighted rows, because for this NAND gate, only the blue color, A dash plus B is one input, B dash plus C is another input. Only the blue color highlighted are inputs. If you compare the first row and tell me, if I use the AND gate, what will be the result of the AND gate? For the AND gate, if one of the input was 0, A dash dot B is 0, B dash plus C is 1. For AND gate, what will be the result? Correct. AND gate will go and check all the inputs one. Go and check all the inputs one. No. So AND gate is going to give me 0. So if AND gate is going to give me 0, what do you think NAND gate should give me? The opposite, right? So opposite means how much? Correct. NAND gate has to give you 1. Using that type, if you go for the second row as well, you have to go and check AND gate, what will be the result? AND gate, second row, what will be the result? And correct. If AND gate is going to give you 0, NAND gate should give you exactly. NAND gate should give you 1. Likewise, if you go for all the row, third row AND gate 0, NAND gate 1. Fourth row AND gate 1, NAND gate 0. Fifth row AND gate 0, NAND gate 1. 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 So you follow the pattern and go. This is how your truth table has to be. Anyone having any questions here? Not in the chat. Let's see. The last before row. Last before row, you go and check is what do you call AND gates logic. AND gate goes and checks what is all the inputs one. Is all the inputs one here? No. So NAND gate gives the opposite of AND gate. If AND gate got you 0, NAND gate will give you 1. Make sense? In the last row, same thing. You go and use AND gate logic. AND gate, you go and check is all the inputs 1. Is all the inputs 1? In AND gate? No. So NAND gate is opposite of AND gate. That's going to be 1. Opposite of 0 is 1. Opposite of 0 is 1. Explain what? I want your questions, man. If you tell me, please explain that doesn't make sense. I want your question. If someone comes and asks me, how did this become 1? That is a question. How did this become 0? It's a question. Why is the last one? That's a question. There's a difference between question. I ask a question. Let me know your question. If you tell me the word I do not understand, that means you are not listening to me the whole time. Ask questions. I can answer question. Okay. So for this question, for the Boolean expression, this part you get 1 mark. For the truth table, if your whole truth table is correct, you'll be getting 1 mark. Again, out of all the columns, only these first 3 columns and the last column is important. And last column, without writing the whole expression, if you want, you can just keep it as X as well. That's also correct. Without writing the whole expression, you can keep the X as well. That's also correct. So for that, you'll be getting 1 mark. Only 1 mark. Huh? So if it's either a NOR gate or NAND gate as a final output, the output becomes opposite from the actual right answer. Uh, if it's a NAND gate, then think first of all how will AND gate's output be, and exact opposite of AND gate, write it. If it's a NOR gate, think how will the OR gate be, and write the exact opposite of OR gate. Clear? Yes, I will be sending in 7. The third row also 0 now. The third row, when you go use the AND gates logic, use the AND gates logic and tell me, in AND gate, if one of the input is 1, the other input is 0, what will be the result? AND gate is going to give you 0. So if AND gate gives 0, NAND gate should give you 1, right? Got it? Before we add the Boolean expression as a column, can we add A dash, B dash plus A dash dot B dot? Yeah, you can. You can then. That's just fine. Yes. You asked to take the opposite of the AND gate, no? Yes. So what will AND gate give you? The third row, A dash dot B is giving you what? B dash plus Z is giving you 0. So using AND gates logic, tell me one of the input is 1, other input is 0. What will be the value of AND gates? 1? AND gate goes and checks all the inputs 1. This is how AND gate works. AND gate goes and checks all the inputs 1. Are all the inputs 1 here? No, it's 0. Correct? How many marks does the truth table consist? Depending on where the question comes. Here they have put this in the, what you called first question. In the first question, each sub question carries 2 marks. So this will carry 1 mark and this will carry 1 mark. But if it's coming under main like question, here it's coming a sub question under the first question. Apart from the first question, if it comes somewhere else, then you'll have more marks comparatively, depending on where the question comes. Most probably yes, sir, but wait. I'll let you know later. Why doesn't it get subjected to the other column's expression in the last column? The reason is because in that always you compare the inputs. Like for example, if I'm going to use all what do you call if you take the column here one of the input, this is an AND gate. The last column is talking about this NAND gate. For this NAND gate, what are the inputs? A dash plus B is one column, B dash plus C is another column. So you have to compare only the inputs. For the respective gate, what are the inputs coming? Only those inputs you're going to compare. That's why I was highlighting and going. So A dash plus B is the blue color columns only you're going to compare. Because only those blue color columns are coming as input for that gate. So when you're checking how a gate works, you first of all check the input that's coming for that gate. You don't have to check the input that's not coming for that gate. Got it? I didn't understand the row theory. These are rows, no. In a table, if you want to figure out the number of rows, use this equation. Simple. Because how it became 2 to the power 3? Because there are 3 inputs in this circuit. A is 1 input, B is 1 input, C is 0 input. And 2 to the power 3 is equal to 8. You replace the number of inputs. The index of 2 is number of inputs. So this question had 3 inputs, A, B, and C. That's why it became 2 to the power 3. Again, I'm telling you all, first play the, why am I telling you all? I directly put it out of the class. Abdurrahman Pai is out of the class. And then, who else out of the class? It's a The recording provided, yes. So is 2 constant? Yes, 2 is constant. Exactly. Next. So 1 mark for this truth table. Normally you get more marks, but in this question only 1 mark you're getting for the truth table. Huh? Ignore that, Abdullah Jifri. You don't have to answer others' questions. I'm putting you out of the chat, out of the Zoom meeting because you are answering others' questions. Only I have right here to answer the questions. Again, I told you the third time I'm telling you. I'm not telling actually. I'm just directly one time telling and one next time out. No, one time telling, that time is allowed. It's fun to put people out of the classes. You see, if it is a physical class, I would have blasted the head also. Can't be highlight. It's good if you can highlight. You can highlight. I actually highlight. Can I do the questions now? Okay, next. Again, I'm telling you, I have the rights to answer a person's question. So if someone put a question in the chat, until I answer, that doubt should be there in the chat. If any of you are going to answer that question, you're out of the chat, even if it is the correct answer you give. So before that, we add the Boolean expression column. Can we add A dash or B dash? You can, you can. Okay, you reply. Thank you. Sorry. And then sometimes you're scary. You all have not seen in physical class. When you ask me in the physical class how good I am, then they'll tell you about it. Do you mean we can highlight the exam? Yeah, you can, no issues. Next, draw the star topology network with 5 computers and write one advantage and one disadvantage of this topology. See, yes, physical place, they know it. Yes, okay. So you have to draw a star topology, right, with 5 computers and write one advantage and disadvantage. First of all, let's draw the topology video. So first of all, I should draw the star topology. Good job, Haya. So in star topology, the main thing what you have is you have a switch or a hub. So I draw like this a device and I label this device as, if you want, you can mention only switch. That's because you know, and what's a bit, what's the answer to that question? That you call, you can mention this only as switch, or you can mention this only as hub, or else you can mention this both switch or hub. Anything is fine. Only switch is also fine. Only hub is also fine. Switch slash hub, that's also fine. And you have 5 computers to be connected. So you can just draw any shapes you want. Okay. You can draw it as a square, you can draw it as a rectangle, anything is fine. I'll just draw it using what you called like squares with a small 1, 2, 3, 4, and let's say 5. So technically in star topology, what happens is all the devices are connected to a central switch or hub. Is there a difference between switch and hub? Yes, there is a very big difference. How is your handwriting so neat for user PC? Meanwhile, resonances and Python answers. Practice. So, exactly. Is switch a must to draw? Yeah, without switch or hub, you can't have a star topology. The main part of star topology is all the devices are connected to a central switch or hub. So without switch or hub, you can't have a star topology. Triangle. Any device, any shape is fine as long as you have a shape to represent. It's good. Taki, yes, you can just WhatsApp me and I'll let you know what to do. Okay. What is the difference? We might come a question it has. When it comes, I'll tell you. Somewhat a difference. In simple, if you are going to ask me the difference, in switch, you can control when the data is transferring. For example, let's say I'm sending the data from here. Okay. Or let's say there's a data stored in this computer. The data that's stored in this green color highlighted computer, if I'm using a hub, okay, if I'm using a hub, all the remaining computers, they can access the green color highlighted computers data. All the remaining computers which are not highlighted, they can access this data that's stored inside green color. By default, everyone can access. But if I'm using a switch, I can control the access. I can control which computer should have the access to the green color computer. So I can tell, okay, only allow for these 2 computers, don't allow for others. So that's the main difference between switch and hub. In switch, you can control who has access. Hub, everyone connected has access to each other computers. Simply. Shouldn't the image be like a star? No. You can draw the image any way you want. The main how the answer is being checked is there has to be multiple devices connected to a switch or hub. You can draw it like this, or you can draw it like this. Any shape you want, you can draw as long as all the devices has to be connected to a central switch or hub. Got it? Is this a topology which has more protection than other topology? No, that's the mesh topology. Mesh only there is highest protection. So shape doesn't matter. Next. They ask me one advantage and one disadvantage. So first of all, I'll mention the disadvantage, and next I'll mention the disadvantage. If you take star topology, the main advantage you have is easy to set up. That's the main advantage. Easy to set up. Okay. And as also the hub sends data to every computer and only the selected computer can access it though. No, not like that. Creating the network, you can control it. Where did we study about this topology? Grade 10 lesson number 2. So the disadvantage we have in what we called the star topology is the breakdown of the switcher hub, the breakdown of the switch or hub can affect the entire network or can affect or break down the entire network. How do you do the three topology? Huh? Not relevant for this question. How does it affect? Yeah, the advantage, the disadvantage. So if we could draw all the topologies in whatever we want, how do we identify the difference between each? The way it's arranged. Each topology is drawn in different ways, man. If you take star topology, it's drawn like this. Okay, I'll draw all the topologies and show you everything. If you take star topology, all the devices are connected to a central node. See how the star topology works. If you take ring topology, all the devices are connected to each other. You can draw in any way you want. I'll draw ring. So for example, 1, 2, 3, 4. Each device is connected to each other. See how the ring topology works. In bus topology, there's a backbone cable or main cable. For this main cable, multiple computers are connected. See how the bus topology works. There's a main cable here. For this main cable, multiple devices are connected. So then you have star, ring, bus, mesh topology. If you have 4 devices, every device is connected to each other. Here to here, 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 and here to here. So topology is not the shape, it's about how it's connected. In star topology, everything is connected to a switch or hub. In ring, every computer is connected to each other. In bus, everything is connected to a main cable. In mesh, every computer is connected to each other computer. Tree is a combination of bus and ring. So you have the main cable. You can have a computer directly connected as well, or else you can have a switch or hub. And to the switch or hub, you can have multiple devices connected. To the switch, you can have multiple devices connected. The how the tree topology works. So in tree topology, it's a combination of this part is called the bus topology. And this part is called the star. So the combination of bus and star forms a tree topology. So topology is basically how it's connected. It doesn't have to be the shape or it don't have any connection. Yeah, Sergeant, sure. If you don't write the switch and hub, is it wrong? You might lose like half marks again. Okay, right. Let's go. Next question. Topology means how devices are connected in a network. Simply, what the definition of topology is how the devices are connected in a network. My switcher hub is like a circle. Is it fine? As long as you have labeled it switcher hub, you are good to go. You can have any shape you want, it should be labeled correctly. Thank you, sir. Here you go. Yes. For those who are asking class details, just I can't reply at the moment because I'm replying a question. So you'll just drop a message to the mass right number, which I sent in the chat. Okay, next. Match the ports in column A with the column B. How many topologies are there? In your syllabus, we are learning only five. In reality, there is more than five. Okay. So when you call up match these PS2 ports are normally found in olden days mouse and keyboard. Have they given mouse and keyboard here? Yes. So olden days mouse, olden days keyboard, you can connect in the PS2 ports. Parallel ports. In parallel ports, you can connect olden days printers and olden days scanners. So you can connect this. RJ45 port, this is a network port. So you can connect Ethernet cable is like internet cable. The word Ethernet means internet. It's kind of like internet. So you can connect the internet cable using the RJ45 port. HDMI port, you can connect the monitor, TV, all those stuffs. So if you connected them properly, this is how your answer has to be. So 0.5 into 4, you get 2 marks here. For this question, for the diagram, 1 mark. Diagram also half marks for the switcher hub and half marks for the 5 computers connected. Advantage half marks, disadvantage half marks. Do we learn the rest of topologies in grade 11? No. That's why I said in your syllabus. Did I say in your grade? Your syllabus, you just have only these 5. Okay, next. Indicate whether the following statements are true or false about word processing software. So in the class, I have not thought about word processing software, but we are discussing a question here because I think that's the kind of syllabus that's coming for the exams. That's fine. Presenting of data using a table. No. Normally, if you take word processing documents, you can present data in the form of tables. But if you take the main purpose of word processing softwares, so example for word processing software is Microsoft Word. So there are actually types of Microsoft Office applications, we call them as. So there's something called Microsoft Word, there's something called Microsoft Excel, there's something called Microsoft PowerPoint, right? Normally to create text documents, normally to create Word documents, just a document where you're going to type text mostly, you might use Microsoft Word. In Microsoft Word, you can include tables. You can create tables like this. Now, this is a table, this is a table, this A and B is a table, right? You can create those kind of tables in Word. But the main part of Word is not to present, but you call data in the form of tables. The part of presenting data in the form of tables, you'll be learning about this in your grade 10 lesson number 7. Okay. So representing data in the form of table, that is done by something called a type of application called as spreadsheet applications. We'll be learning this in the grade 10 lesson number 7. So the main purpose of spreadsheet applications only to present data in the form of tables. So Microsoft Excel, Google Sheets, if you have learned about these applications, they're talking about Excel. Okay. Next, adding color to a page in a document. If you take a page, yes, you can add colors to a page. You can make a Word document colorful, one page, one color. It is possible. Actually, this is possible in a Word document, but that's not the main purpose. So because it's possible, I'll mark it true. Yeah, but that's not the purpose. The question is not very, very precise. Analyzing a sample of data using a line chart. Wait, I'll put the first one as false because they have mentioned here the word processing software is used. They're asking indicate whether the following statements are true about Word. No, it's about Word. If you're saying Word is used for presenting of using data using tables, not suitable, so I'll mark it as false. Adding color to a page in document, yes, possible. Analyzing a sample of data using a line chart. Normally, you will be learning about these charts. There's something called line chart, pie chart, bar charts. So, like in maths, you'll learn about pie charts, right? Just like those pie charts or histograms in maths, you might have learned sometimes. If you have not learned yet, in future, you'll be learning, okay? So, these charts are something. No, seventh lesson will not come, only after sixth lesson will come. In the seventh lesson, you'll be learning about those charts. But these are what charts, no, these are line chart. This is how a line chart would look like. This is a column chart. Okay. So using these charts, we can actually analyze data. That is something you'll be learning again in the seventh lesson. So that's also incorrect. Analyzing a sample data using a line chart, that's mainly done using the spreadsheet applications. So ignore this point as well. Creating personal letters of for a large number of recipients. This is actually correct. In your Microsoft Word, there is a feature called mail merge. I'll talk about this later. Okay, but those who have learned, you all might have heard this word called mail merge. So using that feature called mail merge, you can do this. I'll show how to do this later. Not now, I'll show it later how to do this. Probably at the end of the class, I'll show you all this. But in terms of Word document, yes, you can add colors to a page and you can what you call create personal letters for large document. We call this mail merge. Well, I have not taught this in the class, so I can't explain much because for my class students, they will be confused because I have not explained the whole lesson yet. But if I have learned this in school, I mean, if you're getting for the exam, it's probably you've learned in school, no? But again, you will not get much questions, don't worry. Yesterday's paper class, I thought you thought about mail merge. Yes, yesterday's paper class, I thought about it. No, I'm talking about the grade 10s. So yeah, those are two correct statements. So if you got the first one wrong, second one correct, third one wrong, fourth one correct, half marks each, total 2 marks. So in the online class, when will you do the sixth lesson? Because I'll be getting it for my exam. My target is focusing on overs. Before December, your syllabus will be completed. Okay. It will not be parallel to your school exams. I'll definitely tell you. Because some schools follow one theory lesson, one practical lesson. Some schools follow one order. I'll be starting the fifth lesson in August, sixth lesson in September, seventh lesson in November, eighth lesson, sorry, in October 5th and 6th. Sorry, August 5th and 6th, September 7th, October 8th. That's how the pattern goes. So probably the end of August we'll come to it. Next. But don't worry, you will not get much hard questions that lesson. Without that also you can get more than 80 marks to your paper. For Word, you'll get very few marks. I forget about that. I mean, the parts which you should know. Next. Match the shortcut keys in column A with their what do you call the functions in column B according to word processing software, right? So in these, not only word processing software, majority of the softwares have these features, shortcuts keys, not only Word, even other features, even other softwares also have this, right? In any software you're going to use to copy some data, when you select the data, if you want to copy that data, you're going to click on the Control key plus C. That is used to copy. Not exactly, Amra. What do you call Control plus C is to copy. And to paste something, use Control plus V. So that's going to be connected to this. And once you do something, if you want to go behind, if you go for the previous step, we call the previous step as undo. To undo, we have Control plus Z. To redo, we have Control key plus the Y key. When you press these two keys together, it'll after you come back, you can again go forward. Okay. And then hyperlink, that's done by Control K. Hyperlink is not there in other softwares. This is something respective to only to Word. Okay. But the remaining ones are general shortcuts. So if you know the remaining ones itself, you can just think, okay, these are the balance one and connect it. So keep in mind, Control C is for copy, Control V is for paste, Control something which are not there and important I'll give you, Control Y for redo. And if you want to cut something, it's Control plus X. Cut and copy is almost similar. So if there's two datas, so if there's a data, let's say I want to copy this data from here, and let's say I want to paste it in the second line. So this is, let's say line 1, line 2. So let's say I have a word here. I want the same word visible here. If I want the same word visible in both the places, I should first of all copy this. And after I copy it, I can go and paste it. So after I paste it, it will be there in both the places. But if I cut, what will happen is it will remove from here and it will keep, and after I paste it, will come here. So in cut and paste, it will remove and paste. In copy and paste, a copy of that will be pasted. Okay. Did I tell I'm not in the recording? The seventh unit, part of second term. Certain schools, yes. Certain schools, no. As I know, no. As I know, only until sixth lesson it's coming, as I can remember. But yeah, some schools even seventh lesson is coming. But I will not be doing the seventh lesson here. I'm doing the seventh lesson only in the grade 11 side. Yes, Mario. Okay, so if you got this correct, the matching correct, put half marks each. and half marks into 4. That's 2 marks there. Next, convert the binary number blah 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 into decimal. Okay, first of all, let me write the binary number there. 10101010. 1010 1010. So this is a binary number. They're asking to convert this binary number into decimal. Normally, from any number system, when you want to convert a number from any number system decimal, the pattern is actually the same. Why is it a one? Oops. Okay. So what do you call from any number system you're going to convert decimal? The pattern is same. What you should do is you have to multiply each digit by its place value first. Okay, multiply each digit by its place value. Now, when you're doing what you called your grade 1 or 2 or 3 or 4, I'm not exactly sure which grade, you would have learned something called ones place, tens place, hundreds place, right? Like that, from that, those are called place values, right? From number system, the place value changes. So you can figure out the place value very easily. First of all, what you're going to do is below every number, you're supposed every digit, okay? Below every digit, you have to write the base of that number system. If I look at this number, you can see the base of this number is 2, right? So below every digit, I should write the base 2, 2, 2, 2, 2, 2, 2, 2. So this 2 is representing the base of the given number. This given number's base. Okay. Then you write the position of where this 2 is located. Any number you take, the right side corner digit's position is always 0. The next one's position is 1. The next one's position is 2. So it keeps on increasing by 1. Okay, so keep in mind, we start with 0 and we increase little by little. So 2 to the power 0 is equal to 1. 2 to the power 1 is 2. 2 to the power 2 is 4. 2 to the power 3 is 8. 2 to the power 4 is 16. 2 to the power 5 is 32. 2 to the power 6 is 64. 2 to the power 7 is 128. Now what you do is you multiply every digit by its place value. So once you multiply every digit by its place value, okay, you multiply each digit by its place value. 1 times 0 is 0. 2 times 1 is 1. 4 times 0 is 0. 8 times 1 is 8. 16 times 0 is 0. 32 times 1 is 32. 64 times 0 is 0. And 128 times 1 is 128. So what we do here is we're multiplying every digit by its place value. So this 1 is basically representing the place value. And once you do that, you just add these numbers together. So once you add them together, it's going to be 128 plus 32 plus 8 plus 2. So 128, 130, 160, 170. So once you convert this number decimal, your final answer is going to be 170. Normally, to represent a decimal number, you can keep the number as it is, or else you can add base 10. That's also correct. Both are correct. Got it, all of you? Multiply each digit by its place value, and then add the numbers you're getting at the bottom. If you have any questions, drop in the chat. So answer there is going to be 170, right? Yes, 170. If you mention 170, you get 2 marks there. No need any methods. For method, you don't get marks. Okay. Because the question has not asked. No. If the question had mentioned show your workings, then method is required. If the question has not mentioned it, you can directly mention the answers. Huh? If you don't have the base, will they cut marks? Go and ask your English teacher, what do you mean by the word called or? I told you, right? You can write 170 or else 170 base 10. That means what does it mean? You can write like this or this. Have I written the base here? No, no. I hope can't blame them. Listen. Yeah, you can, Abdullah. Then after class, what's up? Is it a must to write the base? For decimal numbers, base is not must. But for all other number systems, the base is must. Got it? Is it higher? Okay, perfect. Convert the C5 base 16 number into octal. Okay, so C5 base 16. First of all, tell me, this number called C5 base 16, this number is given in which number system? The C5 base 16 is there. Look at the base of that number and tell me what type of number is this? How do you call a number which has a base 16? But you all are more lazy fellows when one is saying HD killer for hexadecimal. Sheesh. Exactly. Base 16 means we are representing the hexadecimal number system. Correct. Okay. Correct. It's a hexadecimal number system. Now, when you have a hexadecimal number, what do you call the typing takes a while? Okay, that's fine. When you take a hexadecimal number, tell me from hexadecimal to octal, are there any direct conversion methods? Direct, no. You can see from decimal to sorry, binary to decimal, there was a direct conversion method, right? Similarly, from hexa to octal, is there a direct conversion method? Yes, Shah. No, you can't directly convert from hexa to octal. So there are two methods for this, okay? So from hexa to octal, you can't, from hexadecimal to octal, you can't directly convert. So because you can't directly convert, there are two possible methods. One is you can convert this to decimal, and the answer you get in decimal, you can convert to octal. This is one method. Another method is you can convert this to binary and convert the binary number to octal. Tell me, what do you think is easy? Which pattern is easy? Convert into binary is easy, or convert into decimal is easy? Which one is actually easy comparatively? Yeah, I call the not Gen Z, Gen lazy. Correct, correct. Exactly. Out of the two, converting to binary is more easy. So what we're going to do is we're going to convert it to binary. Okay. So if I'm going to convert to binary, C5 base 16, if I'm going to convert to binary, how it's going to work is, first of all, you write the numbers in a small gap. No, I have not. Okay. So I write the C first, and then with a small space, I write the number 5. In hexadecimal, we have one small thing. Apart from numbers, in hexadecimal, we use letters as well. No? So apart from what you call numbers from 1 to 9, we use what you call letters as well. Tell me, out of these letters, the letters are A, B, C, D, E, F. These are letters we use. Tell me, out of these letters, A represents how much? For hexadecimal, apart from using numbers from 0 to 9, we have these letters from A to F as well, right? So A represents, correct, A represents 10. F represents how much? Umar Zahra out of the class for replying to the chat. I told you, questions asked in the chat are asked from me, not for you. So mind your business and just reply to the questions I ask, not the questions others ask. Exactly. F represents 15, right? So based on this, A is 10, B is 11, C is 12, like that it goes. So tell me, in C15, the number C15, so C5 base 16, the number C5 base 16, 5 is a whole number, fine. C represents how much? Correct. C represents 12 because B is 11, C is going to be 12. So I write 12. Now what you do is very easy. The hexadecimal to of what you call binary. What I'm doing at the moment is hexadecimal to binary. Yeah? Currently, I'm converting from hexa to binary. Hexa to binary. No. Normally, hexa to binary and octal to binary is a bit similar. The only difference is when you take hexadecimal, every number is represented. For example, I have C5 in hexadecimal. Every number represents how many bits? 3 bits or 4 bits? Exactly. Yes, Maria. What is bits? Bits means binary digit. Every binary digit we call as a bit. Yes, 4 bits. So how this hexadecimal, what do you mean by that is, for example, if I have a binary number like this, okay, how a hexadecimal number is formed is we take 4 bits or 4 binary digits and tell, okay, these 4 bits are going to represent one digit, one hexadecimal digit. These 4 bits are going to represent one hexadecimal digit. That's how this hexadecimal number system is formed. In hexadecimal, what happens is you take 4 bits and tell these 4 bits are going to represent one digit. Okay. So when they were creating number system, Abdullah, I'm going to put you out, Abdul Ansari. Even though you have named your name is Abdullah, you think I don't know your name? Okay. I'll tell you, the last time you asked questions out of the, what do you call the content, I'll be putting you out. Huh? Simple. In the exam, in MCQ, if they ask which is correct, BCD form, I'll tell you, I'll show that in a right. Okay. So what do you call every number represents 4 bits. So when they were creating, when they were earlier days, I think I've told this for several times, but again repeat. Earlier days, they used to write binary numbers. So when they were writing binary numbers, the numbers were too big. So they want to shorten it. Like for example, when you're writing sentences, sometimes you all might write, instead of writing the word I don't know, to shorten this, what you will be doing? You will do IDK. Okay. So that's what you know. Early days also they used to write binary numbers. So when they were writing binary numbers, it was too big. How is it go? That's what I'm explaining. Hey, that's what I'm explaining. Okay. So back then they used to write binary numbers, it was too big. So they wanted to shorten this. Okay. So because they want to shorten this, what they were like is okay, let's without writing the whole binary number again, let's shorten it. And initially they started shortening in a form where they represented 3 bits as one binary digit. They took 3 binary digits and they told, okay, these 3 bits are going to represent one digit. So the number system that was formed where they took 3 bits and represented one digit, that is what we call as octal number. So if you take octal number, behind one octal digit, if you have octal number called 27 base 8, behind this, or let's say for example, uh, 47 base 8, behind this every octal digit, there are 3 bits. Okay. Behind a one, actually, if I convert this to binary, this is how it will look. Okay. Where these 3 bits represent number 7 and these 3 bits represents 4. I'll show the conversions later, but normally what happens is they used to shorten a binary number. So you can see this binary number has 6 digits. After you shorten it, it has only 2 digits, right? So from 6 digits, we are shortening the number to 2 digits. So the process of shortening it like this, where you're going to group 3 bits as one digit, okay? That process is what we call as octal number. So octal number was made by the whole binary number into 3 bits by 3 bits. And later on, they were like, okay, this is not enough. We're going to make it somewhat short. To make it somewhat shorter, they made a hexadecimal number system where they represented 4 bits as one digit. So in hexadecimal, what happens is 4 bits are going to represent one digit. Simple. Does it represent the 3 into to the power of 3? Nope. The conversion is a bit different. If you are a weekend number conversions of what you call number conversions, go to the YouTube, search for Master IT. Once you go to YouTube and search for Master IT, the YouTube channel, you will be getting one whole seminar for number conversions. So all the conversions and how were these number systems formed, who uses a number system, regarding the number systems, everything is there in that video. Let me show it to you. So just go to Master IT, click on this yellow color channel. There is here a seminar called Number Conversion Seminar. So go and watch the second video. Lesson-based seminar, second one, number conversion. That has all the conversions. So if you are weak at number conversions, go and watch that. Anyways, coming back to the point. So how this works is, what do you call below every digit? Now, because I told you every number is going to represent 4 bits, we are going to find what are those 4 bits. So below every number, write the first 4 bits place value. The first 4 bits place values are 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3. If you want to know how this 1, 2, 4, 8 came, again, the solution is to watch the YouTube video, right? But simply how you do is, step number 1, write both the digits separately. Step number 2, below every digit, write 1, 2, 4, 8. If you want to know why this 1, 2, 4, 8 came, again, I'm telling you, watch the YouTube video. Because to explain that logic, it will take at least half an hour of time, which I can't spend here. So now after I wrote 1, 2, 4, 8, 1, 2, 4, 8 onto every digit, now what I'm again 1, 2, 4, 8 from right to left. See 1, 2, 4, 8. So once I wrote 1, 2, 4, 8, I'm going to circle the numbers I need to form the respective digit. To form the number 5, I have to add 4 and 1 together. Similarly, tell me to form the number 12, Out of these numbers, what are the numbers I should add together? To form the number 12 out of 1, 2, 4, 8, what are the numbers I should add together? Now, to form the number 5, I took 4 and 1, right? To form the number 12, what are the numbers I should add together? Perfect. To form the number 12, I should add 8 and 4. So once you add 8 and 4 together, you will get 12. No? So below the numbers you added, write 1. Below the numbers you did not add, write 0. And below the numbers you circled, write 1. Below the numbers you did not circle, write 0 like this. Now you have the binary number equivalent to C5 base 16. So C5 base 16 is equal to, just join them together, double one double triple zero, 1 0 1. This is the value of C5 base 16 in binary. So once you have the binary number, now step number 2. So this is step 1. And now we are going to go for step 2. So step 2 is basically to convert the binary number we have into octal. So why in binary octal, this numbers too big to shorten them, they shorten them into 3 bits by 3 bits. So we have the full binary number like this as 11 000 101. In octal, what did they do is, if there was 0 in front, we can remove it and we can write the binary number. Yes, if there's 0 in front, you can remove it. So in octal, what happened is we grouped them into how that binary number came. Here I joined it now. These 4 digits and these 4 digits. I joined them together and got this binary number. Okay. So this binary number I have, I'm going to convert that to octal. If I get the same answer using different method, is it okay? Yes, you can get the same answer using different method. It's completely fine. So once you have the binary number, to convert octal, you group them into 3 bits by 3 bits, which means these 3 bits represents 1 digit. These 3 bits represent another digit. Here we have only 2 bits. To make it a complete set, I add a 0 in front. Adding that 0 is not compulsory, but to make it nice, I add 0 in front. So one of the set we have is 011. Another set we have is 000. Another set we have is 101. Now what you do is below every digit, write the first 3 bits place value. The first 3 bits place values are 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 0, 2 to the power 1, 2 to the power 2. Basically 1 to 4, 1 to 4, 1 to 4. Below every digit, I write the first 3 bits place value. Okay, so octal is first 3 bits place value. Now wherever there is 0, cut the place value. Ding, 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 ding. After you cut the place value, write the sum of remaining. Here 4 and 1 is remaining, 4 plus 1 is 5. Here nothing is remaining, so remaining is 0. Here 2 and 1 is remaining, 2 plus 1 is 3. Okay, so once you get the remaining of every set, now again join them together. So once you join them together, your answer is going to be 305. And that's the answer. So C5 base 16 is equal to 305 base 18. Step number 1, convert to binary. Step number 2, convert to octal. Anyone having any questions here? Drop in a chat. In the exam and MCQ, if they ask which is correct BCD format, how can you find the answer? In BCD, the largest value you can have is 9. 9 is a decimal number that can be represented largest in BCD, which is 1001. So if they represent 10 using 4 bits, now what is BCD? BCD is representing a decimal number using 4 binary digits, representing a decimal number using 4 bits. That's what BCD means, right? So you can't represent 10, 11, 12, 13, 14, 15. These numbers you can't represent in BCD. The reason these are called forbidden numbers is because BCD is used to represent only decimal numbers. Okay. 10, 11, 12, 13, 14, 15, those are not decimal digits. Decimal number digits are what? Only from 0 to 9. So 10, 11, 12, 13, 14, 15. Even though you can represent these using not 9 base 10. So 9 base 10 is correct. But you called in decimal number, even though you can represent 10, 11, 12, 13, 14. Even though these numbers are represent, you can represent them using 4 bits. Those are forbidden numbers. So the invalid BCD numbers would be 1, 2, 8, 1, 0, 0, 1, 0. Sorry, 1, 0, 1, 0. This is one forbidden number. 1011 is forbidden. 1100 is forbidden. 1101 is forbidden. Then 8, 9, 10, 11, 12, 13, 14 is forbidden. 1111. These are all forbidden numbers. So if they give one of these numbers, then no, that's not a BCD number. Got it, Oshidi? I'm answering your doubts you're dropping in the chat. If there's doubts, drop in the chat. How can I check if the answer is correct? You're asking for the number conversion. I mean, for the this hexa to octal conversion, Zura. Oh, it's cool. We learned a very hard minute. Yeah, this is easy. Man, just follow this. Yeah. So how you check how you put the marks is basically if you got the binary number correct using any methods you want. If you got the binary number correct, that C50 C5 base 6 is equal to this, you get 1 mark. And sorry, you get 1 mark. And if you get that C5 base 6, the binary number is equal to 305 base 8, 1 mark for this. 1 mark for the binary number, 1 mark for the octal. You can use any method you want. Could you re-explain the hexadecimal to binary? Yeah, give me a moment. I use table and got the answer 472. Your answer is wrong. That means is BC binary for decimal? Yes. Because I got 3 here. 2 plus 1 is 3. Nothing is remaining 0. Here 4 and 1 is remaining, so 4 plus 1 is 5. For my exams, if I get a wrong answer but method is correct, will I get marks? Yes, you'll be getting. What is forbidden? Forget about this. I was answering a student's doubt. That is not relevant to your question. Yeah. Okay. So simply, if I'm showing you a step by step how you are supposed to do it in a very normally how you might do in the question in exams, how you might do is in exams you're not going to explain someone how to do the question. No, simply how you might do is like this. If I write it here, erase this. Okay. So C5 base 16. When you convert it to binary, sorry, when you want to convert octal, step number 1, convert to binary. So write C separately, 5 separately. C is representing 12. 1, 2, 4, 8. 1, 2, 4, 8. Circle the numbers you need to form the respective digit. 4 plus 1 is equal to 5. 8 plus 4 is equal to 12. Below the numbers you need write 1. Below the numbers you have not circled, write 0. Then you just join them together. So once you join them together, you'll be getting something like this. So this is the binary number. So once you have the binary number, we're going to group this binary number into 3 bits by 3 bits. So these 3 bits are representing one set. These 3 bits are representing one set. Here we have an incomplete set. To make a complete set, I'll add a 0 in front. So the 3 sets I'll be having is 0, 1, 1, 0, 1, 0, 1. Below every digit, write its place value. 1, 2, 4, 1, 2, 4, 1, 2, 4. And then wherever there is 0, you cut the place value like this. And then for every set, write the sum of the remaining values. Here the remaining values are 2 and 1. Sum of remaining is 3. Here remaining value is nothing is remaining. So sum of remaining is 0. Here 4 and 1 is remaining. So 4 plus 1 is 5. So answer is going to be 305 base 8. Some people are like, the drawing the table and finding the answer is easy. By the time you draw the table, I'll finish the question here. This is the easiest method you can find. I'm not going to teach the table method. That's unwanted. If you directly know it, will we get the marks? Yes. If you directly know the binary number like this, so if you directly know the answer 305, you will be getting the marks. No issues. Because the question has not asked the steps. If the question asked the steps, then no. But in that question I gave you, they haven't asked the steps. So because they haven't asked, if you directly wrote, still you will be getting the marks. Got it? Okay, perfect. Next. So here the answer is 305. If you directly wrote, also you'll be getting marks. If you have mentioned the method, also you'll be getting marks. Both are correct. Okay, next. Indicate the true or false in the following statements regarding the electronic spreadsheet software. Spreadsheet is not there in the syllabus, so I'm going to ignore this for now. And let's go for the next. Those who did the question, actually, again, you can get, if you're putting marks, if you're written only the answer, you can directly put 2 marks. Or if you're written the method, then break it to 1 mark and 1 mark. And tell me, out of 18 marks, how many marks will go here actually? For those who did the question before the class started? Good. Drop in the main chat. But maybe two of you have done the questions. Others, yeah. Check the marks and then not a how much you got. Actually, we'll be doing that in grade 11. If there's any of you all who is getting spreadsheet for your exams, then join the first half an hour of the grade 11 seminar, okay? Because the grade 11 will be starting with spreadsheet. So if you're getting in your school for the spreadsheet seminar, the spreadsheet question, then join the first half of grade 11. Huh? There's the grade 10s who are getting that. Also know it. Or then I'll check later. Um, Not much, Vishendra. Good, good, good. Is spreadsheet an exam? If spreadsheet is there, join the grade 11 first half an hour. What I said was if spreadsheet is coming, join first half an hour of grade 11. Okay, next. Let's go for the question number 2. Draw the logical circuit corresponding to the Boolean expression. Okay, first of all, let's look at this expression and looking at the symbols, let's find out what are the gates used. Huh? Here we can see a dash. The dash represents which gate? The dash here represents which gate has been used. Perfect. The dash there represents the NOT gate. If there's anyone of you all who is unable to find out that, actually after the class, I'll send you all in the Master ID WhatsApp channel. I'll post you all about the summary. So this page has a summary of the logic gates. Like for example, to look at a symbol and identify what gate is it and how does it work. Some what do you call stuffs are there here. I will share this picture in the Master ID WhatsApp channel. So if there's anyone of you who is not in the channel, I'll just share the link. So what do you call you can just join the channel. After the seminar is over, at night I'll share that breakdown. Okay. You yesterday told this I waited, but you didn't. Yesterday I told I'll be sharing the paper class community. Go and check the paper class community. I have already shared it. Okay, next. The plus represents the OR gate. And if you look at the brackets, these brackets has plus in between the inputs and dash for both the inputs. So if you have plus and whole thing dash, plus and whole thing dash represents which gate? The plus and whole thing dash, that represents which gate? Who did that? Correct. That represents NOR gate. Okay. So now I'm going to draw the circuit respective to that. When I'm drawing the circuit, the step number one is look at the whole expression and see what are the unique letters used. So if you look at the what you call circuit, you can see the right after the equal symbol. Look at this part. The unique letters you can notice here are the letter A, B, and C, right? Letters used are A, B, and C. So first of all, I'm going to mention the letters A, B, and C. If it's just AC, if it's just AC bar for C, then how do you do it according to this question? If it's just AC, I'll show. Wait. So step number one, you write the inputs only. Okay. That is write the letters only. So letters here we have A is one letter, B is another letter, C is another letter. Second, to draw this circuit, you have to know the order. Okay. There is like, now, for example, if I give you all a question like this, like what is the answer of 2 plus 3 times 7? Okay. Mathematically, answering this question, what you all might do? You all might do the multiplication first, addition second. That's how you might do, no? We're not doing that. What is the order you're following? Why did you do the multiplication first and addition second? What do you call that order as? In maths, if I ask you to find answer, you might first of all multiply and then addition, right? So that order is called what order? Perfect. We call it as Bodmer's order. Similarly, we know what do you call doing the question here as well. There's the order you have to follow. First of all, you have to work on the brackets. You have to draw what is there inside the brackets. Second, you have to draw what is there inside what is mentioned using NOT gate. Third, you have to draw what is represented by the AND gate or else an AND gate. And finally, you draw what is represented by the OR gate or else an OR gate. This is the order that has to be followed. So as per this order, if you look at, you might notice here, there is the NOR gate used, there is OR gate used, there is NOT gate used. But if you look at the question properly, like I think someone asked a while ago, I missed your name. But you call, they're like, for AC dash, the dash is there only for C. Then how do you draw it? Okay. So what we do is, yeah, BNAO, like banana, it's there. You can remember, okay, banana, again. You can remember. Anyways, you take AC dash, the C dash, the not kid is there only for the C, right? So one thing to keep in your mind is sometimes, representing the AND gate, you can represent the AND gate using dot or else nothing as well. So for example, if you have something like A dot C dash, or else if you have something like A C dash, both are the same. So keep in mind, sometimes not, or what you call the AND gate can be represented without any symbol as well. So if there is no symbol here, that means between A and C dash, they're using the AND gate. Okay, so AND gate, you can write with the dot as well as without the dot. Is that clear, all of you? Got that point? Okay, perfect. So based on that, tell me, if I have something like A dot B, tell me what is another way I can write A dot BS? Tell me what is the other way I can write A dot BS? Perfect. If you have something called A dot B, you can rewrite A dot B as AB. If it's A plus B, okay, can I represent A plus B as AB? Can I represent A plus B as AB? No. If you listen properly, I told you if it is AND gate, what you can do is if there's a dot, you can ignore the dot and write without the dot as well. So that's only for the AND gate, it's correct, not for any other gates. So if it's AND gate, if there's a dot in between the inputs, you can ignore the inputs and write it directly without that dot. Clear? Okay, perfect. So using this idea, there is an AND gate used here. Okay. So apart from this, there's an AND gate used. Yes, I'll be sending the recording in the channel. Okay, keeping this thing aside, now tell me, what do you call out of all these AND gate, NOT gate, OR gate, and NOR gate? Which gate do you think I should draw the first? Now we have these. If you look at the circuit properly, I have an AND gate used, I have a NOT gate used, I have an OR gate used, I have a NOR gate used. Which one should I draw first? Nicely see. I have clearly told you all, first of all, what do you do? First of all, you all go for the brackets. Ajish is out of the class for sending something unwanted in the chat. Boom. Yes. So in brackets, what do we have here? A dot B whole thing dash. So because the NOR gate is there inside the brackets, we are supposed to do the NOR gate first. I said brackets first. In the brackets, what do we have? We have the NOR gate. So therefore, we should do the NOR gate first. So if you look at the NOR gate, you can see A and B are the two inputs. So I take A here, I take B here. I connect the A and B through the NOR gate. So now I have A dot B whole thing dash coming from here. Is that part clear of you? Is this part clear? Because A dot B whole thing dash was there in the brackets, I did that first and I drew it here. If there's any questions, drop in the chat. Huh? Next, now I'm done with the NOR gate. What is the next gate I should do? NOT gate, OR gate, or AND gate? Correct. Out of NOT gate, AND gate, and OR gate, I should do the NOT gate first. So NOT gate has what? C becoming C dash. So I pass the C through the NOT gate. And once C goes to the NOT gate, C is going to become here C dash. So that's also done. After NOT gate, what's the next one I should do? AND gate or OR gate? One person is asking if we change the order, will the answer be wrong? I told you, right? This is like BODMAS. So use your mathematical knowledge and tell me in maths for a BODMAS question, if you mess up the order, will the answer be correct or wrong? Same answer is for this. Correct. We're going to use the AND gate first. So AND gate, you can see it's A dot C dash, right? So I have to take A. You don't draw the A again, right? What you can do is you can take a connection from A like this. So if it is clashing with another symbol, take a small curve. If it's clashing with another symbol, take a small curve. So I connect the A and C dash now using the AND gate. So this is going to give me A dot C dash. A dot C dash and dot C dash dot A both are the same. Don't worry, when you all ask questions, I don't mention your name. So as long as the question is valid, even if it's an easy question, I'll answer. Don't worry. Listen to the recording. I answered that question 1,000 times. So I'm going to answer it again. And next, if the curve is the other way, is it correct? It is correct, but avoid it. Draw the curve like this. This is better. Okay, fine. So now I have the A dash dot B, A plus B whole thing dash, A dot C. These two are done. I have these two. The final gate we should draw is the remaining gate we have is what? We have the OR gate to draw. Okay, is it a must to draw the curve? Yes, it's must. In certain questions, they might miss it. That's a printing mistake. But in your questions, it's a must. Okay. Anyways, the remaining gate is OR gate. I'm going to connect both of them in the OR gate like this. So once I connect them in the OR gate, my answer is going to be like this. So there's a Q is equal to that. So I wrote Q here to represent it. What is spreadsheet? Why do you want a spreadsheet now? So I'm going to get out of the class. Amma is out of the class for asking something irrelevant for the class. It's completely not there. Anyone have any questions? If there's any questions, drop in the chat. Huh? The next question they're saying construct the truth table for this. So truth table should have for every input one column. So A is going to have one column, B is going to have another column, and C is going to have another column. Apart from every input having one column, every output also has to have one column, right? So the first gate output I have one column called C dash. Another gate I have is A dot B whole thing dash. So A plus B whole thing dash. And another column I have is A dot C dash. And another column I have the Q. So I can write Q as this. I normally prefer writing the Boolean expression. So the Boolean expression for Q is actually A dot C dash plus A plus B whole thing dash. Now, if there's both OR and NOR gate, are we supposed to do that from left to right? Your wish. No, there's no difference. You can go left, right? No problem. Even if there's two brackets, you can use any brackets you want. No issues. Does input have to be in alphabetical order? Not exact, but better. Okay. In this, what do you call logic circuit, we have three inputs, right? So tell me, if there are three inputs, how many possible combinations, or else how many rows will it have? Correct. We have three inputs here. That means 2 to the power 3 rows. 2 to the power 3 is how much? 8. So there are 8 rows that will be there here. 1, 2, 3. Truth table columns. Every input has one column. A, B, C. These are three inputs. So every input one column. Every output one column. Every gate has output. So every gate's output is going to have one column. 1, 2, 3, 4, 5, 6, 7, 8. Now you start filling the truth table from right side corner input. So here out of A, B, C, C is the right side corner input. Just fill in the pattern of 0, 1, 0, 1, 0, 1, 0, 1. Next input, double it. So two zeros, two ones, two zeros, two ones. Next input, double it. Double of 2 is 4. So four zeros and four ones. So you always start the right side corner input, 0, 1, 0, 1, 0, 1, 0, 1. Next input, double, two zeros, two ones, 2 0, 2 ones. Next input, double, four zeros and four ones. Then you start filling other columns as well. C dash means opposite of C. So if C is 0, C dash is 1. If C is 1, C dash is 0. So if you fill in this pattern, just write the opposite of C column here. Okay. So if C was 0, C dash is 1. If C was 1, C dash is 0. Just the exact opposite of the C column. Next, we have A plus B whole thing dash. So A plus B whole thing dash is represented OR gate. No. So A plus B whole thing dash is represented NOR gate. NOR gate is equal to the opposite of OR gate. Right? Opposite of OR gate. So what you do is, first of all, imagine in OR gate how it will be and write the opposite of that here. Okay. Go on this pattern change. No. So OR gate, you go and check, is any of the inputs 1? I showed you earlier. So here A and B are the inputs. No. When you compare A and B, let's take for the first row, A and B. When you compare and see, is any of the inputs 1? No. So no means 0. Right. So OR gate is going to give you 0. If OR gate is going to give you 0, then NOR gate should give you 1. Similarly, go and check, is any of the inputs 0? So if any of the inputs 1? No. So opposite of no is yes. Is any of the inputs 1? Yes. Opposite of yes is no. Is any of the inputs 1? Yes. Opposite of yes is no. Is any of the inputs 1? Yes. Opposite of that is 1. Is any of the input yes? So is any of the input 1? Yes. Opposite of that is 0. Is any of the inputs 1? Yes. Opposite of yes is no. Is any of the inputs 1? Yes. Opposite of that is 0. So what I've done here is I went and checked for OR gate all the results, and then the opposite of the OR gate's result I mentioned there. That's what was done here. And I checked only the first two columns. The reason is because only A and B is going through the NOR gate, which we have there. This is graded. Yes, at 7:30. Next, when you tell A dot C whole thing dash, A dot C dash. A dot C dash, we're going to compare the A column and the C dash column. A dot C dash. Using the dot. Dot represents what? The AND gate. Okay. Dot represents the AND gate. So use the AND gate's logic, we're going to compare A and C dash. AND gate goes and checks, are all the inputs 1? For that AND gate, A and C are the inputs? No. When you compare the yellow color column and you check, are all the inputs 1? No. 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 Are all the inputs 1? Yes. Are all the inputs 1? No. Are all the inputs 1? Yes. Are all the input 1? No. So you compare the two yellow color columns and see row by row, all are 1, all are 1, all are 1, all are 1. All are 1, you write 1, or else 0. That's how the AND gate works. AND gate goes and checks, are all the inputs 1. The next column has A dot C dash plus A plus B whole thing dash, which means you're going to compare the A dot C dash column, that is this column, with A plus B whole thing dash column, between this column, these two inputs are compared using the OR gates logic because plus represents the OR gate. OR gate goes and checks, is any of the input 1? When you look at the first row and see, is any of the inputs 1? Yes. Is any of the inputs 1? Yes. Is any of the inputs 1? No. Is any of the inputs 1? No. Is any of the inputs 1? Yes. Is any of the inputs 1? No. Is any of the inputs 1? Yes. Is any of the inputs 1? No. And if you got it correctly, this is how your truth table is going to look like. Anyone having any questions here? So for this, normally in terms of marks, you might get what do you called? For the circuit, you might get 5 marks, means 1, 2, 3, 4. Half marks, sorry, C dash is opposite of C column. So if C is 0, C dash is going to be 1. The complete opposite of it. Is it wrong if the pattern is wrong in the truth table? You can mess up the row order, but the rows has to be correct. That means when A, B, C, when all three of them are 0, answer has to be 1. When A, B, C is 0, 0, 1, answer has to be 1. When A, B, C is 0, 1, 0, here it has to be 0. So the row by row, it should be correct. If you mess up the order of the row, it's fine, but the respective row has to be matching, then only your answer is correct. So if your answer is correct there, you get for the truth table, put 2 marks. For this circuit, put 2 marks. Next. If there's any questions regarding this question, ask. Huh? An alarm system is required to be installed in school for security reasons. Relevant sensor should be installed at office entrance or. Okay, so there are some sensors that has to be fixed in the office entrance, it seems. By knowing that answer, what are you going to do now, Atif? Are you in grade 11? No, no. You're in grade 10? No? Focus on the grade 10. Actually, yes. What's up? Right? So, yeah, there is a sensor in the office entrance, it seems. And no, Nafa. See, not K at first. Because that's C dash, no. It's A dot C dash is you have C, you have a column, see the yellow color column. You have C dash column and you have A column. So we're going to compare only those two. If it was A dot C whole thing dash, then yes. Here is no, if it's A dot C whole thing dash, no goes. Okay. Okay, perfect. So when you compare the office and there's the question, the Roman number 2, they're saying for office entrance, there's a sensor. For the computer lab, there's a sensor. In the storage room, there's another sensor, it seems. So there's sensor O, sensor C, and sensor S. And these sensors are connected for alarm system. Let's see how this alarm system works. Huh? The next one they have mentioned, if someone tries to open these doors, so there are office entrance is one door, computer lab is one door, storage room is one door. If someone tries to open these doors, the system should be alerted. Okay. Draw the circuit for the school alarm system according to this scenario. Note that door is open means one, alarm state is one. Okay, fine. Now, as per the question, tell me, for the alarm to ring, should all three doors be open? Or, I mean, like practically think, think and tell me, for the alarm to work, should all three doors be open or if any door is open? Any or all? What kind of idea does the question give? Instead of Q1, any other question for the table come with the marks be 6 or more than it? Depends. For second term, you have more, but for third term in grade level, will be less. Yes, Hasna. What time will be finishing? We'll be finishing with this question actually. I want to discuss the fifth question as well. My plan was to discuss after the second question, fifth question. Mm, let's see. But yeah, until 7:30 we'll be going. Yeah, exactly. Any door. So when you say any door, so there are three doors here. There are one sense is then the office entrance door, another sense is then the computer lab door, another sense is then the storage room door, right? So out of these three doors, any door has to be open door. To represent the idea, the logic of any, we have the OR gate. So the answer would be something like this: O, C, and S. Three of them. OR. And this is how alarm will work. Have they mentioned alarm is equal to what? No. So we are mentioning alarm. So the alarm, there are three doors, O, and C, and S. If any of these doors are open, what do you call? How about now? Still lagging? All right. Still is it lagging? Okay. So we have three sensors, O, C, and S. So if any of these sensors are on, or if any of these doors are open, the alarm will ring. So this is how it's going to work. If you got this diagram correctly, actually I can give more. Wait, for this diagram, I'll put 2 marks. And for the Boolean X, for the circuit, I'll give more marks actually. So 2, 4, I have 6 marks I can give you. So 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. If you got, if you drew this NOR gate correctly, I'll put 1 mark. Not get correctly, 1 mark. And get correctly, 1 mark. Is 1 mark. So 1, 2, 3, 4. And in this table, if your first three columns and the last column, if these are there, if the first three columns, the order is written properly, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is not how the real marking scheme works, but I'm just giving you all like this. Can we draw it like this in the second paper, or do we have to take two of them first, then other again? No, you can draw directly like this. Directly, you can draw it like this. All three inputs to one bit. Last question they are saying, for the if someone tries to open these doors, the system should be alerted, right? So that means if either one of these doors are open, the alarm has to ring. And they have said when a door is open, the sensor is going to give the signal one, right? So if any of these sensors give you one, any of them give you one, you want the alarm to ring. And alarm ring means is equal to one, right? So we want a gate to be used between these sensors in such that if any of these sensors gives you one, alarm will ring. So the OR gate gives the idea of what OR gate gives the idea of if any of the inputs give one, output will be one. So OR gate will go and check is any of these doors open? Is O open? Is the office room entrance open? Or is the computer lab open? Or else is the storage room open? If any of them are open, alarm will ring. Make sense? That's also correct, Zumba. Okay, now tell me, out of 10 marks, how many marks will have here? Is there any specific amount for columns in the truth table? Every input has to have one column. That means A, B, C columns are definite. These are important. See, A, B, and C are inputs. No? So every input should have one column. And the final output, that's Q is there. Q has to have one column. So every input should be there and the final output should be there. These are the minimum columns a truth table should have. Got it, Samir? Every input and a final output. But for more clarity, it's better you have for every output one column. But important is the first three and the last. That is all the inputs and the final output. Good, 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 good. Okay, let's quickly go to the fifth question. That was the next question I want to discuss actually. Third and fourth are number. The third one is complete theory. It's very direct. Fourth has certain conversions. I'll come to that later. I don't think I'll be doing it today, but I'll go for fifth one now. Why is it stuck? Why is it stuck? Yeah. Write two examples each for volatile memory and non-volatile memory. So in your computers, there are two types of memory. One is volatile and one is non-volatile. The difference between volatile memory and non-volatile memory is if you take volatile memory, For these devices to be running, for these devices to work, you need current. Okay. Once current is gone, once power is gone, it forgets everything. Once current is gone, forgets everything. Imagine something like this. Imagine you are typing a WhatsApp message. And while you're typing, WhatsApp has a feature called draft, but forget about WhatsApp. Let's say you go to your, what do you call, laptop, and you take, what do you call, or you go for a browser. You went for a browser like this. And let's say I was typing something. While I was typing hello world here, before I clicked on it, I didn't even complete my sentence. Before I complete the sentence, if my laptop off, I'm typing some word, I didn't still complete the sentence. Before I complete the sentence, if the laptop gets off, will this word be there as this when I re-on the computer? So I'm typing this word here. Suddenly, let's say something went and the laptop got off. So after I on the laptop again, will that word be there as it is? No, it won't be there as it is. That is how volatile as well works. Okay. That is how, what do you call it, volatile also? Yeah, that's how the volatile also works. In volatile devices, what happens is when there is current for the device, for the storage device, the data will be stored. Once the current is lost, the data will also be lost. Okay. So based on that example, and non-volatile is opposite. Non-volatile, even if the current is lost, still, but you call without current also, the data will be stored. So if you have typed, like for example, if you have stored a data inside that, when the current goes and comes, still the data will be stored. That's how non-volatile work. So within your computer, some examples for volatile devices are, we have the RAM. Apart from RAM, we have the cache memory. These are the two volatile devices we have. For non-volatile devices, you can mention ROM, and any other secondary storage device you can store here. So hard disk, CD, DVD, these are all non-volatile memory. Is that clear of your pen drives? Any secondary storage device you can mention here. Okay. Under volatile, you have only just two examples. For your syllabus, you all have learned only RAM and cache. I don't think you all have learned any other ones. What does cache do? It temporarily stores data that's frequently used. Okay, next. Write the classification methods of computer according to technology. So if you take computers, if you're going to categorize computer, there are two ways you can categorize computers. Okay, types of computers you can categorize based on two things. One is based on the size and one is based on the technology. So based on the technology, when you're categorizing, we have something called as analog computers. No, Raya. We have digital computers and we have something called as hybrid computers. In terms of size, we have something called as supercomputers, mainframe computers, mini computers, and microcomputers. So these are the classifications of computers. So in this question, they're asking based on the technology. No? So based on technology, it's analog, digital, and hybrid. Half marks, half marks. He also half marks into two. If there's any questions, drop in the chat. Huh? Next. Name the parts defined by the letters A, B, C, D in the diagram. Okay, in this diagram, they're showing how the computer functions. This is actually a diagram that's there in your grade 10, lesson number 2. Make sure you have a thorough idea of this, right? How the computer functions. Normally, if you take a computer, all the data will be coming from an input device. Okay, data will come to the computer through the input device. So once the data comes to the input device, first of all, it will come to your main memory, which is your RAM technically. Mostly it will come to the RAM. When you're mentioning main memory here, mostly we're referring to the RAM. So what this RAM will do is RAM will see has this data should be processed or not processed. If the data has to be processed, the data will be sent for the CPU. So this portion is there, right? This portion represents the CPU. So only if the data has to be processed, it will be sent to the CPU. And in the CPU, first of all, the data will come from the memory registers. And after the memory registers get the data, the processing is going to be done by ALU. After ALU does the processing, it will again return back the data. Okay. So once you have that data with you, if you want to show that data back to the user, then you can send that data to the output devices. Okay. And if you want to store the data permanently, then you can store that for secondary storage device. So here the connections are A is representing secondary storage, B is representing input device, C is representing output devices, and input device. Give me a moment, guys. Okay, input device, output device, secondary storage, ALU. So A is representing secondary, B is input, C is output, and D is ALU. So this is how the computer functions, or how the data flow is there inside the computer. Okay, then non-volatile will store if there's a power problem too. It's not about that, man. Once you store data, now for example, if you take your computer, download some files from the internet. Okay, and you take your phone. Your phone, let's say you go and download a movie or you download a song. When you download that movie or song, by default, that movie or song will be stored inside your phone's internal storage. Okay, so once it's stored inside the internal storage, once you restart the phone, still the data will be there, right? So if you restart and the data is there, it's non-volatile. If you restart and the data is not there, it is volatile. So if you download the music, it's there, right? That's why it's volatile. So it's non-volatile. Got the idea? That's cool. What is A? A is representing the secondary storage devices. Instead of secondary storage, I put secondary memory. That's also correct. Secondary memory is also correct. What time is grade 11 starts? 7:37. 7, actually grade 11 is starting at 7:45 because I had a pray and come, obviously. If possible, one more time the process. So the process, how it works is the data will start from the input device. So from the input device, the data comes to the computer. It first of all lands at what you called the main memory. So once it comes to main memory, if that data that comes has to be permanently stored, then we send that data for the secondary storage. If it has to permanently store. If it has to be output, then we send it for the output device like this to see. If the data has to be processed, it will be sent for the CPU. So this whole section we call as CPU. In the CPU, there are three sections: the register memory, ALU, and CU. So if it has to be processed, it will be first of all sent to register memory. From register, it will be sent to the ALU. And after ALU is done processing, it will come back to the register memory, come back to the RAM. And if it has to be output, it will output. If it has to be stored permanently, we'll go for the secondary memory. Got it? Yes, Sana. Okay, so that's the answer for the Roman number one. Roman number one, A is input device. Sorry, A is secondary storage device, B is input device, C is output device, and D is representing the ALU. Next, name two examples for A, B, and C. So for A, we can say examples, input device examples, you can say keyboard, you can say mouse, you can say microphone, any devices, any input device you mention, you get your answer correct. I'll give the marks later, okay? Because I don't know the exact marking of this. Once I do everything, I can tell you. But if you have mentioned those examples, you're good to go. ALU is mathematical operation. So if it's not a mathematical operation, we go through ALU, right? ALU does two things, arithmetic and logical. So like, for example, checking are two things correct, are two things wrong, are two things present, are two things absent. Even logical processing is done by ALU. Any thinking that has to be done, anything that you normally do with your brain, like thinking you do with your brain, is done by ALU. That's why we say arithmetic and logical. Arithmetically maths. Logical is the thinking. Got it? Arithmetic and logical unit. Maths and logics. Will you be giving a break in between 10 and 11? Yes, I will be. A is secondary. Yes. Secondary memory. Sorry. My bad. B is only input device. Yes, sorry. So for B, you can mention keyboard, mouse, all those stuffs. For A, you can mention what you called hard disk, or else memory cards, pen drives. Why is it stuck? Okay. And pen drive. And then what do you call? You can mention any other secondary storage, a CD, DVD, anything is fine. Okay. Next. I put solid state device, optical storage device, magnetic storage device. Those are not examples. The questions asking examples, no. So when you say examples, you might get marks sometimes depending on who's marking your paper, but probably they might not give you marks because those are not examples. Those are classic categories. So avoid right now. For example, for input device, you can the category we have some the mouse comes out of the category of pointing device. So if you mention pointing device, even though it's correct, not suitable. Yes, Rashida. Then C. So C is replacing output device. For output device, you can mention monitor. Then you can mention speaker. You can mention printer. All of them are correct. Okay. And then if you take what you called only for ABC, they have asked exams. So these are what the PDF I'll be sharing in the WhatsApp community after all the seminars are over. That's probably after the 10, after 10 p.m. Now the grade 11 will be starting around 7:45. These are grade 10 still. Okay, next. Name the two types of communication media and write two examples each. So in terms of communication media, the data, how can the data be, the communication media means how can the data be traveled from one place to another? Data can be traveled in two ways. One is wired and one is wireless. So one is a wired media, also known as a guided media, and other one is a wireless media, also known as an unguided media. So for guided media, you can mention the example, or the wired, you can mention examples as one thing you can mention is the coaxial cable. Then you can mention the fiber optics cable. And then you can mention the twisted pair cables. If you want, you can be more precise. Shielded twisted pair cable, unshielded twisted pair cable. You can be more precise. Or you can just also mention twisted pair cables. Twisted pair cables, you're good to go. And then for wireless media, you can mention what do you call infrared, radio waves, and microwaves. Okay. So these are the examples you are supposed to mention here. What about digital analog signals? No, they are not types of communication media. Those are types of signals. Touchscreen for input and output, correct. Ethernet, Wi-Fi. Ethernet is not a what do you call cable. That's called fiber. Most of the Ethernet cables are fiber optics cables. So you mention Ethernet cable, it's wrong. It's not a type of cable. Like mentioning Ethernet cable is like mentioning phone charger cable. The phone charger cable is an example for twisted pair cable. So here they're talking about the types. Oh, they're asking for examples, right? Then if you mention what you called Ethernet cable, you might get marks because most of the Ethernet cables are fiber optics. So you can mark it correct. Will it finish with the fourth one? Yes, correct, Charlotte. Okay, the last question for the grade tends to over. Yes, yes, grade 11 will be starting at 7:30. This grade 10 still going on. Actually, 7:45, the grade 11 will start. Write an advantage and a disadvantage of computer networking. So, networking is where the devices are connected together. Okay. So, the advantage of computer networking we have is one thing is you can share data, share files easily, share files, data or information, or let's say share data or else files between devices easily. This is the main advantage. Apart from sharing files, you can share resources. Like sometimes in your school, if you go and see the printer, in the office, there might be three computers, and all three computers are using the same printer. So we call this as sharing resources. Your printer is a resource, all of them are sharing. So share resources such as printer. That's another example you can mention. So these are the two main advantages we have. Apart from that there are more as well, but these are two main advantages we have from networking. Like you can mention what you called it consumes less storage space as we can have a centralized server or as we can have a centralized storage place. Like if you're making a sentence properly, you can mention less storage as we can have less storage as we can have a centralized storage space. Security is correct, but that's not the answer I would expect. Email, without mentioning email, the most suitable one you can mention is communication. So email is also correct, security is also correct, but those are all not very precise answers. Huh? These are some answers you can mention advantage. They are correct, security and email as well, but I would recommend you all to go with these answers than those answers. Communication, I would not ask you, right? That's a very low bar answer. I mean, it's a, to go for like very precise answers. Don't go for those easy answers, which can go wrong. Because certain questions, if they give you a context, sometimes they might give you a context in us. In certain context, security will not match, email will not match. But first and two is will be matching for 99% of the plots. In terms of disadvantage from computer networking, the disadvantage we have is one thing. What do you called? It requires no. That is internet. No. For disadvantage of network, you can mention possible network breakdown, possibility of network breakdown, possibility of network breakdown. That means the whole network can break down. Then possible security issues like virus, possible security issues like virus, requires training to implement and use. Spy is not things are suitable. Spy is an example for security issues, so that's not as a point, right? Not suitable. And you can mention requires a architected. You can mention requires what you call a setup fee. To set up the network, there's amount that has to be paid. So a costly to maintain. That's also correct. Ransom can attacks. That's all possible security issues. Ransom as an example for virus. Cyberbullying again. That where can you find cyberbullying in networking? This is not. They are not talking here about the disadvantage of what you call social media. They're talking about disadvantage of networking. You know, if you can't cyberbully network, you don't know networking is where we have devices connected together. You can't chat. All if okay, the grade 11s don't know the rules here. The grade 10s will know. Rule number one: if there is any chat dropped in, if there's any so grade 11s who have joined here, we'll be starting grade 11 around 7:45. But I'll just tell you all the rules. Normally in the chat, if anyone messages, only I am supposed to reply. If any of you reply that message, you're out of the chat. You can ask the grade 10s how many people I put out. Okay. So this is a warning I give for Alif because Alif, I think you're in grade 11 from Poland now, right? So because you're not there in the grade 10 sessions, I'm giving you the warning now. If there's any question in the chat, it's only for me to answer. You can answer your put your questions on the main chat or personal chat. You can ask it anywhere you want, but only I will answer. Yes, survey out at the moment. Anyways, for the grade 10, we're going to stop from there. I did not do the two questions, which is the third and the fourth one. From the this third and fourth, because third is direct questions and fourth is number conversions. But keeping that thing aside, based on what we learned, if you have any questions, drop in the chat. And after all the seminars are over, I will upload this PDF, the field version with the third and fourth questions field as well. I'll upload it in the Master ID WhatsApp channel. Those who have any questions related to grade 10, the grade 10 people, those who have any questions, you all can stay and ask. The grade 11s will be starting at 7:45, so you all have to wait. The grade 10s, anyone having any grade 10s who are still here? If you have any questions, you all can stay, or else you all can leave. Any grade 10s have any questions? Drop in the chat. No, grade 11 will be starting at 7:45, so you can wait. Grade 10s, I'm checking your question in the chat. Yes. Hello. Welcome. That cyberbullying is related to some incident in our school. I guess he's in our school. Oh, I see. There is no cyberbullying in a network. Means cyberbullying is something that can happen in social media, not in network. Can you explain about cache memory? Yeah, cache memory is there in your now, for example, when you open a website, for example, let's take YouTube. You can see this logo of YouTube in every page. Now, if I go and open this video, when I'm playing any of this video, this logo at the left side top corner. What meant is done as block. The annotation was kept in this zone. Anyways, you have the logo in the left side top corner, right? So this logo will be visible in every page I go, right? So normally by default, this logo will be stored where? In YouTube's server. So when I open the website, it will go and load the video. Now, every time I load the website, what will happen is it will not go and load the image again and again. What it will do is when it loads the image, that image that was loaded, it will be stored into the cache memory. So when I reload the same page, it will not again take from the internet. Instead, it take from the cache memory. I'll show a good example for you. I'll go for the Mastodon website now. To load the Mastodon website, it's taking me 1, 2, 3 seconds. Around 3 seconds it took to load. Like after you saw the yellow color for the image to load, it took around 3 seconds, right? I'll refresh the website now. One. See, within 1 second, it was there. See, when I'm refreshing, within a second, it's not even you can't even see that time it takes to load that image. But I'll again show you Control F10 F5. Now you see it'll take 1, 2, around 3 seconds it's taking 3, 4, around 3 to 4 seconds it took to load both the images. Because now when I loaded it, I did something called hard refresh. But if I'm just refreshing it, it loads quickly. See, when I refresh quickly, you can't even see this image and this image loading. But if I do hard refresh, again do and see, it'll reload both the images. Control F10 F5. When I'm doing hard refresh, Control F10 F5. See, it's loading both the images, right? So that is because it's loading from the server. So when it's loading from server, it takes time. When it's loading from the cache memory, it loads quickly. So the reason is because this logo here, this low image here. So when I jump from pages to pages, you can see the image is still there. The reason it's there is because those data, that image is actually cached. This image is stored in the cache memory. So when I'm going from one page to another page, it can store it quickly, or it can give it to me quickly because it's not retrieving from the internet. Instead, it is storing in the cache memory, and from the cache memory, it's giving to me. Got it, Tasma? Yes, Tasma. The grade level will be starting at 7:45. So wait. Any device, if it has a cache memory, that's how it works. Okay, perfect. You're welcome, Matthew. Okay, I think In what way can a network break down? Network breakdown. We learn about the topologies, right? The topology, that's how you create a network, right? So if the switch is broken, then the whole network is down. Imagine, for example, you have a bank. Imagine the bank, there are four computers connected. Okay. And all these four computers, let's say, are connected. We have one, two, three, four. Let's say all these four computers are connected to, let's say, a switch. And for this switch, there's a server connected, or there's another computer connected. Let's say all the data are stored in this main computer, in this server computer, or in the other computer, only all the data are stored. So whenever these are the four staff's computer, the bank staff's computer. Whenever they want a detail about one of the customers, they'll go and fetch from this computer. Okay, from this computer, they will fetch the data. So all these people are getting data from this switch. Actually, like this. Shoot, Adani Singh, Kala. Anyways, what do you call it's getting from the server computer, right? So in that case, if the switch is broken, now the whole bank has to be closed, right? They can't get the customer's details. It is their server. Correct, Deepa? Yes, I will be doing the spreadsheet in grade 11. Yeah, Zumba. Grade 11 will be starting in the 5 minutes. Wait. For a moment. Anyone else having any questions regarding switch and hub? I explained. Mahdi, if your school requests, not a problem. Just drop me a WhatsApp message and I'll tell you. Okay, perfect. So as there's no other questions regarding grade 10, with that the grade 10 is over. Those who have any other questions as well, the grade 10s, or can WhatsApp me at this number and I will get back to you. So the grade 11s will be starting. Oh, it's 7:45. Sorry on the delay. We'll be starting the grade 11s in 5 minutes. Just give me 5 minutes. I'll quickly come. Think I answered all the questions. Yeah. Yes. So let me get the paper first. Sorry on the delay, guys. The grade 10 got a bit late. This because finished. So therefore, the grade 11s will be starting at 10 minutes. So Uzair, ask them to WhatsApp me and I'll get back to you. Okay.